here with a few questions which might turn up in your examination. My first question here is show that 5 times 3 times 2 plus 3 is a composite number. So what basically is a composite number? A composite number is any number which is not prime. Okay, they are not prime. So now how can we show that this number here is not prime? So to do that, let's write this down here. 5 times 3 times 2 plus 3. Now what we're gonna do here is just gonna take 3 common here, 3 from here and 3 from here. So we'll be left with 5 times 2 plus 1. Now why 1? Because we took 3 common and there's 1 here, like because 3 is basically 3 times 1, right? That's why. Now here we have to solve this right here. So let me write this down. 3 times, now 5 times 2 is 10, then plus 1, then that will become 11, right? So now we're gonna write that down here. So 3 times 11. So 3 times 11 is 33, which is definitely not prime because it has more than two no more than 2 factors. Like 33 has 3 times 11, or maybe I shouldn't write this down like this. So it has 3, 11, 1 and 33 itself, right? So there are 4 and not 2. So that means that this is a composite number. Okay, the next question is we have to find whether if there's any value for x such that 6 powered to x is 5. Okay, now how to do that? So now we know that if any number should end with a 5, like if any number say x5, like x is the tens place, okay, so that should be divisible by 5. The prime factorization should have a 5 somewhere, right? Because without a 5 you won't get a 5 in the ending. So if we do the prime factorization of 6 power x, we're gonna get 2 times 3 to the power of x. Now here, if you notice, we are not having any 5, right? No 5s. We don't have any 5s. So that means that this number here is not divisible by 5. So what we can write here is that the prime factorization of 6 power x is 2 times 3. There might be any powers, okay? 2 times 3. Now, next, what we need to write is a very important sentence. It should be there in every question which is asked this way. So now we need to write by uniqueness, okay, by uniqueness of the fundamental theorem. I'm just going to write fundamental theorem. The fundamental theorem. There are no prime factors for 6 power x other than 2 and 3. Okay, so and then you're going to write one more sentence which is going to be in the end, which will say therefore 6 power x never ends with 5. Okay, moving on. This is the last question. So 2 bells ring at intervals 24 minutes and 36 minutes respectively. If the bells ring together at 9 a.m., okay, then at what time they will ring at the earliest? So earliest basically means next, like immediately after 9 a.m. when will they ring together? Okay, so now let's try and take the LCM of these two numbers, because we need to find the least time it'll take for them to ring. Okay, so now the LCM of 24 and 36, right? Now let's do it by the prime factor method. So now let us write down the how 24 can be written in its prime factor. So I'll do it here, so if you do not understand. So 2 goes 12 times in 24, and 2 goes 6 times in 12, 2 goes 3 times in 6, and 3 goes 1 times in 3. So now how this will be written is as 2 times 2 times 2 times 3, right? But here we're going to go 2 power 3 times 3. Now next we have to write it same thing with 36. Okay, so now I'm going to show you how to do the 36 as well right here. So now you're going to write 36 here. Okay, now 18 times 2 goes in 36, 2 times 9 goes in 18, 3 times 3 goes in 9, and 3 times 1 goes in 3. So now this is going to be written as 2 times 2 times 3 times 3, which is 2 part 2's times 3 part 2's. Now let me write this down in a simpler way. I have written down together because now we know how to find it by doing this method, right? Now to find the LCM, now to find the LCM, we have to see what common these two have. Now I'm just going to make a line here to write what's common in them, so I can see that 2 part 2 is common in both of them. Now you'll be thinking that is a 2 part 3. How can you say it's a 2 part 2? Well, basically 2 part 3 is 2 part 2 times 2, right? So now 2 part 2 is common. So when I take 2 part 2 common out of here, okay, I'll be left with a 1 here, and I'll be left with the 2 here. Okay, so I'm just going to keep that now, and then move on to the next one. So I can see there's a 3 common as well. Now times 3. So now same thing with 3 part squared is 3 times 3. So there's 3, right? Obviously we can cut the 3's off. We'll get 1 3 here. So now when I do that, I'll be left with a 3 here. Okay, and this will turn out to be a 1. Now you can see that there are 2 more extra here. For LCM, this doesn't work. We have to make this whole 1. Now, now for HCF, this works. This is the HCF of these two numbers. But for LCM, we are supposed to include these two. So now we're going to write this down on the side as times 2 times 3. So that's basically 2 to the power of 3 times 3 squared. Okay, now let us solve this to get how much time it takes, right? So 2 part 3 times 3 part 2, so that to get the time. Now 2 times 2 to the power of 3 is 8, and 3 to the power is 9, and we know that 9 times 8 is 72. So they will ring after 72 minutes. But now we have to find the time when they will ring, right? So now what we're going to do is 9 o'clock it rings, right? And we know 72 minutes is same as 1 hour and 12 minutes, right? So we can add 1 hour 12 minutes to it, and we're gonna get our time, which you might have already guessed is 10:12 a.m.